mechanical properties, right? Right. So this is the question. Question number 208. Give me the question, please. Can you bring it? Question number 208. Right. Second question. It is given that a uniform rope of mass m and length L on which a force F is applied at one end. Then find stress in the rope at a distance x from the end where force is applied. A is area of cross section of the wire. So a uniform rope of mass m and length L on which a force F is applied at one end. Means at the other end there is no force, let us say. Only force is acting on one end. Then find the stress in the rope at a distance x from the end where the force is applied. You can consider like the wire is attached at one end and this like this for at the other end force is applied. Otherwise, just simply you can also consider this is a wire, and this end we are applying the force F. And let us consider this is x is equal to 0 and this is x is equal to L. Means it is having length L, and it is also given that it is having mass M. It is having mass M. Then the force F is applied at one end. Then find stress in the rope at a distance x from which distance x from the end where the force is applied. From here at a distance x, what is the stress is the question. So the same thing you can consider this case also. You may understand it clearly. Let us consider its total length is L. Total length is L. And now we have applied a force F here. So at a distance x from the end from where you are applying the force, let us say this is point x, okay? At this distance, at this point, what is the stress is the question. You know, stress is nothing but force by area. Stress is equal to force by area. Stress is equal to force by area. If you know what is the force at this point, then you can understand what it is. Because the mass, it is some mass and it is uniform dot. So mass is distributed uniformly. So what is the force at this end? An entire mass, when force F is acting, at this point only this mass will be there. So this mass may not contribute when for the force to be calculated. That means to understand this force acting, F is equal to, if you observe, force is nothing but, and the total length F force is acting. This is X means what should be the length of this rod? Total length is L minus X. L minus X length. On L minus X length, what is the force? You have to understand. Then on this, what is the stress you can understand. So force is equal to, yeah, you can say having mass M. This way I can say total rod having mass M is F. Then force per unit length. Force per unit length can be taken for unit length. If you take for unit length, you can take it as uh, on L length F. On L length F force is acting. On unit length, on unit length F by L, F by L. Whereas on L minus X length, L minus X length, can we take it as on L minus X length? This force is F dash here. F is total force acting here. Let us say the force here is F dash. So that is this thing. So F dash is equal to force per unit length into length of that above part of the wire, that is F by L into L minus X. This can be expressed as further F into, send this L here, L by L becomes 1 minus X by L, it may write. Depending on the requirements here, the options you have to simplify this one. Okay, this is the force acting over here. Then obviously this force here is nothing but force at that point you have to take. Force at that point F dash by area. Area is same only. So you can take this as equal to F dash is F into x minus, 1 minus x by L by area. So in the options what they have mentioned, they have taken 1 minus x by L form only. So if we can take it as f by a into 1 minus x by L. F by a into 1 minus x by L. F by a into 1 minus x by L. Yeah. So this is the stress is required at this point. Right? There is next question number 8. The question is, the length of a metal wire is L1 when a tension in it is F1, and L2 when tension becomes F2. Then find the natural length of the wire. Is that the length of a metal wire is, the length of a metal wire is L1 when tension in it is, tension in the wire is F1. Tension is F1. And L2 is in the, and the length is L2 when the tension becomes, when the tension becomes F2. The tension becomes F2. We find natural length of the wire. Then find natural length of the wire. Then find the natural length of the wire. So, no need of looking at the options, just to let us try to understand how to work out this kind of questions. Length of a metal wire is L1 when tension is F1, means force acting here is on this is F1. So let us consider like this. This is a wire, and this is a force F is acting, means a tension develops in this is, tension develops in this is F1, this point is T1. This force is F1. So here tension is nothing but F1. Correct? So when the length is L1, the length is L1, tension is this. So because of this, it may have some area of cross section A, and it will have some, because of its nature, some Young's modulus, etc., etc. So it may undergo some extension, hmm? Some extension delta L. So length of a metal wire is L1 when tension in the wire is F1, and L2 when tension becomes F2. That means to say this is that means the total length. The total length is L1. You can take, not this is the delta L. The total length is L1. Hmm? Then this total length becomes L2 when the tension becomes F2, means force becomes F2. So the same amount will act as tension here T2, right? So of course having the same wire only, so having same area and same Young's modulus because of the nature of the material is same. So now what you can understand, what you are asked to find, then what should be the natural length of the wire? Its length is L1 at tension F1, means actually it is not actual original length. Original length should be less than this. This is nothing but, here what you have to understand is L1 is nothing but its natural length. Let us say L1 is equal to, let us say natural length is L. So the natural length L plus some extension will be produced delta L. Hmm? So L plus delta L in first case, L plus delta L in first case will be equal to L1. Delta L1 you can say, is equal to L1. So delta, in this case, delta L1 can be expressed as delta L1 is equal to L1 minus L. Can you take it as L1 minus L? It's a natural length. Let us say this is equation 1. Whereas in the second case, the total length is L2 is equal to natural length plus the extension produced due to different tension, different length may extend. So delta L2, let us say. Sum of original length plus extension length, total is equal to L2. Total length is L2 and the tension is this, or force is this. So this implies the extension produced is delta L2 is equal to L2 minus L. Let us say this is equation number 2. Got it? So now what we are asked to find what is natural length. Means what is natural length, we have considered this as L. L is the natural length, right? And what is L is the question. So to understand this, let us take these are the equations here. Okay. Delta L1 is this, delta L2 is this, right? Yeah. But we know that extension produced in a wire as y is equal to f L by a into delta L in general. From this extension produced is can be given as delta L is equal to f L by a into y. So this is in general the extension produced in a wire. So in the first case, extension produced is given as L1 minus L. That can be taken here as the first case delta L1. This is equal to L1 minus L. This is equal to this. So when this extension is produced when the tension is T1, right? F1, F1. So here in place of F you have to take F1, and the original length you have to take it as L only, and by area is same. Young's modulus is also same. Let's take this as equation 3. Then delta L2 from this. Delta L2 can also be expressed as L2 is equal to L2 minus L. L2 minus L is equal to here F in place of F we have to take F2. F2 L by A into Y. Let's take this equation 4. Now if we take the ratio of this, we may get what is this by this delta L1 by delta L2 is equal to, or you can say 3 by 4 implies L1 minus L divided by L2 minus L is equal to this by this. Here F1 L by AY, F2 L by AY. These are all common. So AL gets cancelled, and finally you get F1 by F2. We're asked to find L. To find this, you have to let us cross multiply. Then L1 F2 minus L F2 is equal to L2 F1 minus L F1. Now we want L. So L terms, let us separate one side. So let us bring this that side. So what will get L F2. So and if you take L common, then this implies you get L F1 plus L F2, right? So L into F2 minus F1. F2 minus F1 is equal to, let's bring this here, then we'll get L1 F2 minus L2 F1. So this implies L is equal to L1 F2 minus L2 F1 divided by F2 minus F1. This is the natural length. So you can also just change the order by taking this side. If you take minus out, then or if you bring this side, you can write it as by taking minus. You can write what is that? If you take minus common, this is a positive term, so it becomes minus L1 F2. This becomes plus L2 F1 by F1 minus F2 it becomes. So that way also will be depending on the options again. You have to understand how to simplify this or how to rearrange this. So L1 F2 minus L2 F1 by F2 minus F1 is given. Question number 12. Question is the stress versus strain graphs for wires of two materials A and B are shown in figure. If YA and YB are the Young's moduli of the materials, then which of the following options is correct? Options are given. The graph is given like this. This is the stress, this strain. Stress on y-axis, stress is given on y-axis, and on x-axis, strain is given. And it is mentioned that this is rho, and here two graphs are looking like this. This is A, and this is B, right? And this angle is 30 degrees, and this angle is 60 degrees, right? So options are given. So which of the options is correct? Option says that first option says YB is equal to 2YA. Second option says YA is equal to YB. And third option says YB is equal to 3YA. Fourth option says YA is equal to 3YB. Which option is correct is the question. We know that slope of stress strain curve gives modulus of elasticity. Here in this case Young's modulus gives modulus of elasticity. Here Young's modulus is Young's modulus, right? In general, modulus of elasticity. Slope means here tan of the angle. So in general, if you have any graph, stress strain graph like this theta, then tan theta is slope. That means this is y-axis, this is x-axis, this is delta y, this will be delta x. So tan theta equal to delta y by delta x. This is slope, actually speaking. So but here directly the value, the coordinates are given, you can find out this slope. Slope is equal to tan theta. You don't need to take in tan theta. Slope equal to this. But if you know angle is given, without taking this directly, you can take the slope is equal to tan theta. Right? If angle is given, only to take the coordinates. So here the slope is nothing but slope is equal to tan theta. This implies this slope is equal to tan theta. This gives you Young's modulus. So slope of the first curve, slope of curve A is equal to tan curve A is making an angle of 60, right? Sin 60 is equal to Young's modulus of curve A, right? So, but we know this implies YA is equal to what is tan 60? So tan theta can also be expressed as sin theta by cos theta. If you remember directly, you can take it as tan 60 means sin 60 by cos 60. Sin 60 is root 3 by 2, cos 60 is 1 by 2, so to cancel you get root 3. How much? So if a particular value if you want, tan 60 is equal to sin 60 by cos 60. Sin 60 is root 3 by 2, it is 1 by 2, so to cancel you get root 3. So tan 60 is equal to root 3. Alright, so it is root 3. Equation 1. And YB. So slope of B is equal to the B curve is making an angle of 60 degrees. This is B curve is 60 degrees with x axis, so we will take 30 degree, yeah, 30 degree with x axis. So let's take it is equal to tan 30 degree is equal to slope of YB, a beaker, that is nothing but Young's modulus of that beaker. So from this you can say this implies YB is equal to tan 30 is equal to sin 30 by cos 30. So tan 30 the same way as like this. Tan 30 is equal to sin 30 by cos 30 is equal to 1 by 2 by root 3 by 2. 2 to cancel, you get? So tan 30 is equal to 1 by root 3. Tan 60 is root 3. Tan 30 is 1 by root 3. Now these values, if you substitute here, it is equal to 1 by root 3. Let us say it is equation number 2. From equations 1 and 2, you can say 1 by 2. Let's take 1 by 2. Ya by yb is equal to ya is root 3, yb is 1 by root 3. Right? So this 1 by root 3 goes to numerator and becomes root 3 becomes 3. Right? So this implies we can say ya is equal to 3 into yb. This is how we can get this relation. So ya equal to 3 yb, which option is right? Ya equal to 3 yb, option 4 is right. Right? This one. So question number 40. Right? Question number 40. It is given that two wires are arranged as shown in figure. The elongation in upper and lower ends are respectively. The question is two wires are arranged as shown in figure. Are arranged as shown in figure. Shown in figure. The elongation in upper and lower wires respectively. Respectively. Upper and lower wires. Upper and lower wires respectively. Different options are given. So no need to look at the option, just we can calculate, try to calculate. Let us look at the wire figure. It is mentioned that it is shown in figure, right? The figure is this. There is a rigid support to this. A wire is attached here having length L1, area A, and Young's modulus Y1. And to this a mass M1 is attached. M1 is attached. And to this another wire is connected here, whose length is L2, same area, and Young's modulus is Y2. Hmm? And to the at the end of this one, another mass M2 is attached. So now the question is, what are the elongations produced? The elongation in upper and lower wires respectively. So what you have to how to treat this is you have to treat it as for the upper wire. This is the wire. So you have to take like this. This is M1, M1. This is M2. You have to consider that on this wire, this entire mass is acting. So total force on this is F1 is equal to mg. That m is nothing but m1 plus m2 together are acting as force. Weight on this, right? And this is producing an extension delta L1. So delta L1 on this is usually from Young's modulus, as we know, because Young's modulus of y is equal to FL by A into delta L. From this delta L is equal to FL by A into y will come here. So here it is F1 L1. Its length is L1. Its wire is its length is L1. So its Young's modulus is y1 and area is A. So F1 L1 by area is A and Young's modulus is y1. This so this can be expressed as because of this. So it is equal to F1 is this M1 plus M2 into G. So you can write it as M1 plus M2 into G L1 by A Y1 is the elongation produced in the first wire. That's it. Whereas for the second wire, the same thing. For the this part of the wire, what you have to do is the elongation produced is due to the force at this end, and you have to consider this one. This wire is attached to this support. This support act like rigid support for the below wire. So for the second wire, whatever this is M1 is here. So and here we have attached M2. Right. So this act like a rigid support for this, and from here you have attached M2. So F2 force acting on this is nothing but this pass into G, that is M2G only. But it is having length L2 and Young's modulus Y2 having area A. So we can say that. So the elongation produced in this delta L2 is equal to F2 L2 by A into Y2, right? But F2 here is M2G, so you can write delta L2 is equal to M2G L2 by A into Y2. This is the elongation produced in the second one. This is how you have to take this question. Okay, this is L1, this is L2, delta L1 and delta L2. Right? That's it. Question also once. The question number 2. The question is a uniform rope of mass capital M and length capital L on which a force F is applied. The force F is applied at one end. Is applied at one end. Then find the stress in the rope. Find the stress in the rope. Then find the stress in the rope at a distance x from at a distance x from the end end where force is applied. At a distance x from the end where the force is applied. In bracket it is given that A is area of cross section of the wire. A is area of cross section, of the wire, right? So options, different options are given. Okay, you just don't need to take the options. You can try to find out this. Okay, but of course, sometimes based on the options, you have to simplify. So that's why just you have to look at the options also. So you can see here. See, it is given that this you can consider. A uniform rope of mass m and length L. Like let us consider this is a uniform rope of mass m and length L, or you can consider this watch. One end is attached here, another is free, having length L and total mass m. Right? On which a force F is applied at one end. At this end, a force F is applied. Right? Then find the stress in the rope at a distance x. At a distance x from the end where force is applied. From this end where force is applied at distance x, what is stress is the question. At this point, if you want to know the stress is equal to force by area. Here, stress is total force F by area, but at this point, the same force will not act. A different force acts because mass is distributed uniformly. So F dash by A, let us say. Area will be same, but F is not same. F changes. So what is the force at this point? To understand it, you let us consider on total length L. Here, a force F acts. If you divide this into number of units, on unit length of the wire, total force acting is F by L on unit length. On 2 units of length, into 3 units of length into 3 on here, if you want the force, force is applying here, right? So uh, on total length from here there up just on here total length F is acting. From here, what is the length of this part you should know. So if this is x, this is L, then L minus x is the length of this part, above part. So a force on unit length is F by L. Force on L minus X length is F by L into L minus X. That is our force here acting F dash. You can take it. F dash is equal to force on this length. That is force on unit length F by L into length of this part is L minus X. Right? So then stress is equal to 4 F dash by A. F dash is this. So you can say it is F into L minus X by L into A. If the options is given like this, we can take stress is equal to 4 F dash by A. It is equal to F dash is F into L minus X by L by A area. So if this is there in the option, you have to take this one, but this is not there in the options. So 1 minus X by L format is there if you look into the options. So you have to divide this L with this L. Then we can write it as it is equal to F by A. If we take out, then L by L minus X by L you have to take. L by L is 1 minus X by L you have to take. Then you will get this one. So that's why I'll simplify it. You have to just look into the options carefully and you have to just try out. Okay?
So fourth one, I'll try two more 10.
So it is the figure, let us take clearly. Hmm? Yeah. So the question is, in the given graph, extension E of a wire of length 1 meter of length L is equal to 1 meter is suspended from the top of a roof. This is, let us consider, he is the wire is suspended from top of a roof. Is a wire top of a roof at one end with a load W connected at the other end. With a load W connected at the other end. If cross-sectional area of the wire is 10 power minus 6, A is equal to 10 power minus 6 meter square, Young's modulus of the material of the wire is, what is Young's modulus of the material of the wire? So, and for this, extension versus weight graph is given like this. For 20 Newton load, extension produced is 1 into 10 power minus 4. This y-axis is on y-axis, E into 10 power minus 4 is given, means for every value you have to multiply this. So 1 into 10 power minus 4, 2 into 10 power minus 4, 3 into 10 power minus 4, 4 into 10 power minus 4 is the meaning of it. So this on the x-axis, the weight is given in newtons, means it is 20 Newton, 40 Newton, 60 Newton, 80 Newton. For 20 Newton weight load, extension produced is 1 into 10 power minus 4 meter. For 40 Newton load, extension produced is 2 into 10 power minus 4 meter. For 60 Newton, 3 into 10 power minus 4. For 80 Newton, 4 into 10 power minus 4 meter is the extension produced. So what is it? With this values of length and area for this, with this data, how to find Young's modulus? We know that Young's modulus is this. So you can take direct y is equal to F L by A into delta L, where force is nothing but this one. This itself is force. You can also say the weight is nothing but force is weight, it is equal to mg. So for any one of the weight you can consider. For 20 Newton, this is the extension for this. So if S is it is, we take it as W1. You can say take it as W1, W2, W3 like that. W1 L by A into delta L1. It is extension is taken as E, so we are taking it as delta L1. So it is equal to here for W is equal to 20 Newton. E is this in 1 into 10 power minus 4 meter. If you take this here, then you will get W1 is 20 into length is 1 meter by area is 10 power minus 6. It is given here into for this corresponding extension is 1 into 10 to the power minus 4. This is equal to 20 by 10 power minus 10. If you bring it here, it gives 20 into 10 to the power 10 or 2 into 10 to the power 11 Young's modulus, Newton per meter square or Pascal. So that is how you know. So graph based questions are very more important in different whatever means the chapter. So y is equal to 10 to the power 11 Newton per meter square or Pascal. It can be expressed in terms of Pascal also. Why? If the length of this wire is reduced to L by 2 and radius R by 2, then what is the Young's modulus? Let us say y dash is equal to what? Options are given as y by 2, 2y, y and 4y. So what you have to understand here is Young's modulus depends only on nature of the material of the wire. So if you have a wire made up of say copper, there is a copper wire having length L and radius R. Same copper wire having length L by 2 and radius R by 2. Then it will not change. Just a second. Hello. Continue. 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 Night car. The repetition of okay. Like, like, modulus depends only on the nature of the material. With respect of this, it will be same only. Y dash is equal to y only. Right. Next,
12.
12. See here somewhere. Yes, yeah, this one, right? 12. So, what you have to understand is, if you have a stress strain graph, sinks modulus. From Hooke's law, stress is a constant called modulus. So, modulus equals stress by strain. So, slope gives Young's modulus. In this, for a wire, Young's modulus, or in general, any modulus of elasticity. So, here, Young's modulus. So, but if the angle made by the wire is given, then you can say slope is equal to tan theta Young's modulus. Slope equal tan theta, that gives Young's modulus. So for the first is tan 60, it is Ya. This Ya is equal to root 3. For second wire, YB is equal to tan 30, it is 1 by root 3. So if you divide these two, then you will get Ya by YB is equal to root 3 by 1 by root 3. Root 3 becomes, root 3 into root 3 becomes 3. So Ya equal to 3 by B.
Said slope is equal